This is a video on finding the work done when emptying a tank. The question states, a conical tank that is 4 feet across the top and 3 feet high is full of water. How much work is done by emptying the tank by pumping the water over the top? The first step is to draw a picture and look at work. So our picture is a cone. We could see that it's 3 feet high, 4 feet across. And we know that our work is the force times the distance. So first let's work on the distance. If we have a cross-section that's x feet above the bottom, then that means we're going to have 3 minus x feet left to go, because the total feet is 3, but we've already gone x, so it's 3 minus x feet. So we can see that our distance is 3 minus x. Now the force is equal to the density times the volume. In this case we have water, and the density of water is 62.4, and that's pounds per cubic feet. The cross-section, the volume is going to be the area times the thickness. The thickness I'll call delta x, it's a little tiny thickness, and the area of a circle is pi times r squared. So we need to find r in terms of x, and to do that we're going to use similar triangles. And what we have is that r is to x as 2 is to 3. 2 because the radius of this circle is 2. Now solving for r gives r is equal to 2/3 times x. Now let's put this together, and we can see that our little force is the density of the water times the area times the little width. And then finally, what I did is I put the numbers together, and I got about 87.1 x squared times delta x. Okay, now let's put the force and the distance together. And that'll give us our little work to lift that small cross-section up. And our force times the distance is 87.1. Here's our distance, 3 minus x, times our x squared delta x. To get the total work, we add up all the work for each of these cross-sections, take a limit as delta x goes to 0, and we'll end up having an integral. So the work is the 87.1 times the integral from 0 to 3, because the smallest x gets is 0, and the largest x gets is 3. And then the 3 minus x, x squared dx. I worked this integral out, and what I got was 588. So we know that the total amount of work done is 588. The units are foot-pounds. And I'm done with the problem.